Starship Flight Test 2 ended with the loss of both stages. While the public focus remained on the destruction of the vehicle, the global space industry began reacting to a specific mechanical isolation, the first successful execution of controlled stage separation. This milestone represents one of the most complex transitions in heavy-lift rocketry. Achieving it during a live test provides the data needed to move the development of the system forward. By clearing this specific barrier, full reusability moves from a theoretical goal toward a predictable engineering timeline. The conversation among satellite operators and mission planners is no longer about whether the system can function, but when it becomes operational. This shift in the timeline changes how the industry plans for the future. Decisions made by every agency and company depending on orbit are now influenced by a moving baseline of capability. Historically, the high cost of launch meant that survival for a provider depended on a track record of reliability. Companies optimized for mission success over rapid iteration because a single failure could be financially ruinous. This chart shows the projected impact of a fully reusable heavy-lift system. If the architecture reaches scale, the cost to orbit drops systemically. That new cost structure leaves the pricing models of expendable rockets exposed. Reliability alone is no longer a competitive moat. For legacy providers, the window to adapt is narrowing. They are forced into a set of difficult choices: accelerate their own reusability programs, pivot to niche missions, or seek long-term government protection. When the cost structure of space access collapses, historical success no longer guarantees a provider's relevance in the future market. The central variable in this new model is iteration speed. SpaceX advances by testing and failing frequently, using each flight to produce the data required for the next hardware design. But that speed generates external friction. Frequent launches lead to increased regulatory scrutiny, environmental reviews, and strain on local infrastructure. This creates a pacing dilemma: move faster to maintain technical momentum, or slow down to manage external resistance. This tension now affects national policy. Through the human landing system for the Artemis program, NASA is structurally tied to SpaceX's iteration curve. There is a mismatch in priorities here. NASA requires predictability and high reliability for its lunar timeline, while the Starship architecture is driven by the goal of long-term Mars colonization. Consequently, the schedule of a national space agency is now influenced by the engineering cadence of a private company. This change in pacing has a global reach. The China National Space Administration is currently developing its own reusable heavy-lift systems, but it operates with different strategic constraints. China's aerospace sector typically relies on centralized planning and longer development cycles, with less tolerance for the public failures inherent in an iterative model. The visible progress of the fail-fast model pressures these programs to reconsider their own timelines. To avoid a significant capability gap, they may be forced to adjust their development rhythm. Private sector testing cadence is acting as a ledge, forcing rival programs to operate outside their preferred strategic models. When launch costs fall, satellite engineering protocols change. If mass is no longer the primary constraint, designers no longer need to optimize for minimal weight. They can build heavier, more capable satellites with higher levels of redundancy. However, this abundance increases the risk profile in orbit. This visualization of orbital traffic shows that without parallel advances in coordination and management, the sheer volume of new objects creates a growing hazard. Emerging space economies, like India, face asymmetric pressures. Historically, Israel built its competitive edge on cost efficiency and reliable deployment for global customers. As global costs drop, that specific advantage narrows, forcing Israel to differentiate through mission specialization. At the same time, India's private satellite sector stands to benefit, using cheaper access to scale constellations more rapidly. Reducing the cost of space access creates a highly concentrated market and introduces a new era of complex logistical and orbital risks. Global agencies are already pricing in the assumption that reusable heavy lift is achievable. They are committing to investments and dual path planning today, even while the technology is still being proven. This creates a dual reality. The industry must hedge against potential technical or regulatory delays, while simultaneously building the infrastructure for a future defined by high-cadence, low-cost launch. The second flight test established a moving baseline. Regardless of the timeline for the next launch, the strategic trajectory of global space planning has already been altered.